Breaking news in the medical world. Lots of controversy has been made over the recent discovery found at a Mexican clinic. This past April, the very first three-parent baby was born. This was made possible by moving the DNA from the egg of the mother who had mutated mitochondria into a healthy donor egg. The egg was able to be fertilized. Brought to you now are very special individuals. Here with us live is the birth mother and the doctor who made this possible. Mrs. Jordan, Dr. Zhang, I'm thrilled to have you here with us today. We can't wait to hear your story. How are you all doing this evening?
Hello, Jeffrey. Feels great to be here.
Feeling exuberant. Can't wait to tell you about this wonderful breakthrough.
So how did you feel when Dr. Zhang introduced this notion to you?
Well, after having to go through 2 full pregnancies, both resulting in the same formation of lead disease, I knew there had to be some other way to have a healthy baby. When Dr. Zhang first told us about possibly being able to have a healthy child, we were a bit hesitant. At the time, I already had a child who was incredibly ill with Lee syndrome, but my husband and I decided to test our chances and give it a try.
So, Dr. Zhang, how did you come up with this possible solution? Have you done the procedure before?
I had done the procedure once before in 2003. I had tried the method in China, but the scenario was not quite the same since the mother had given birth to premature twins.
So, was the procedure successful?
Well, the procedure was sadly unsuccessful. The twins didn't make it, even though their mitochondria were normal. When this opportunity came to me, I knew that I could help this couple give birth to a lively baby. All I needed was one egg with healthy mitochondria in order to fertilize. If I could get one, then their baby would have a significantly better chance of being born in good health. This is the outline of the procedure I carried out. On the right, we have a healthy female egg donor whose mitochondria are normal. I used her mitochondria and discarded her maternal nuclear genome. In place, I used the birth mother's maternal nuclear genome, which is showed on the left. By combining the two with the sperm, I created an embryo with normal mitochondria using just the 3 genetic sources. The very beginning of this change is expected from the cell investing less energy in interphase. This stage is a period of the cell cycle during which the nucleus is not experiencing division, regularly happening between mitotic and meiotic divisions. This little abnormal change in the chromosomes during cell division brings about a single mutation that later on results in a greater collection of unusual mutated cells, which for this case is the mutated mitochondria.
After experiencing this disease firsthand, I started researching further into it. Studies show that the older the woman is, there tends to be more mutations in her cells. This happens because as we age, our cells continue dividing and mutant genes begin to be expressed. It was a surprise to find greater rates of mutations in their children, however. Researchers believe a similar mutation process occurs both in the cells of the mother's bodies and in their germlines.
Unfortunately, the show is coming to an end. Before we sum it all up, I'd like to thank Mrs. Jordan and Dr. Zhang for sharing their story. So today we learned what a mitochondrial mutation is, how it affects a person's well-being, specifically who the disorder affects, and what phase the mutation takes place, what is required to make an embryo with a normal mitochondria from a mother with a mutated mitochondria. And we also have some fun facts for you guys. Even by using another person's mitochondria, their physical characteristics still will not be expressed in the offspring. Only the nucleus would have that effect on the baby. Mutations can occur pretty commonly. Some just take many cell divisions to be expressed. Also, X-linked genes that are carried by the mother affect the male offspring, but only because the female offspring to carry the gene.